Greetings, students. Welcome to this topic on digital social research, which is the third topic of this course, Technology and Society. In this topic, we are going to talk about two types of data that is commonly used, understood, and analyzed in the day and age of the digital, particularly looking at the idea of big data and in the next part, looking at the idea of thick data. So, before I go into talking about big data and thick data, there are certain terminological clarifications that might be helpful for you to understand how online research terms are defined. So, what you see on the screen is a table with some of the types of research that can be carried out in an online environment, starting with the idea of internet social research, which is a notion related to both the of online communities and to the study of internet users, as well as products of online culture or human bot interactions. The second type of research term that you may have come across is networked social research, which is a notion describing online and offline community research with the possible additional use of quantitative tools. The third type of research that is commonly used is digital social research, which is a notion describing online community research with the possible additional use of traditional research methods such as interviews and observations. The fourth type of research term that is commonly used is virtual social research, which is a notion of defining the research of online communities only in their online context, which is like research of avatars, including bots. And the final type of research term that you may have come across is the idea of ethnography, which is a marketing research method based on virtual qualitative analysis, which is not connected with ethnographic research per se. So, what we will look at now is a very brief conceptual clarification of what is a method and what is a methodology, and then going into understanding what the ideas of big data and thick data are. So, as you know, method is the way that we conduct research, and methodology is the principle based on which our choice of the method rests. And the research circle, as you are seeing on the screen, talks about a cycle of a journey from theory to hypothesis to data and to empirical generalization. So, if this starting point of research is theory or a hypothesis, and then en route you gather data and go towards empirical generalization, that starting cycle is often talked about as deductive research. And if your starting point is the data itself, and you're starting with data, and then you're going towards generalization and theory building and maybe proposing hypothesis, that is what is usually termed as inductive research. So, what we find is that a research paradigm is often informed by the ideas of ontology, which is a concept I will explain in this lecture, and also influences and is defined by the idea of epistemology. And so ontology and epistemology define, influence, inflect research paradigms. And in turn, epistemology also influences the idea of methodology or the principles or the theory based on which we make a choice of choosing a research method. And this methodology also influences method. So it's a cyclical relationship that you see, that research paradigms are informed, defined, and inflected by the concepts of ontology, epistemology, methodology, and methods. So, with this is also tied the understanding of knowledge representation. And this is where we need to take a deeper look, because at the digital turn, what happened is um, not only that the way we do research has changed, the way we represent that knowledge, the way we analyze that knowledge has also changed. So, what is knowledge representation? Knowledge representation is a set of ideas about how to organize information in ways that facilitate recommended inferences, a language in which we say things about the world. So it's very broad in that sense, that how we analyze and how we visualize and how we make meaning of knowledge that we gather, and then how we want to represent that knowledge. So, one way of looking at this knowledge representation is the idea of big data. And how is big data conceptualized? How is big data defined? And what is the methodology that is guiding, that is behind the scene of the working of big data? So, big data, you will find a variety of definitions of big data in the literature. But overall, what these definitions sort of direct us towards is a suggestion that big data possess three key traits. And these three key traits are volume, velocity, and variety. So, as you can imagine, that the volume refers to the sheer mass, size of big data that makes that data big in its volume. Velocity refers to the momentum of the data, the momentum that the data inherently has in itself, that it is not static, it's not a static data set. And variety speaks to the type, the bounty of data that is captured under the umbrella of big data. So, variety also points towards the idea that big data is also linked data. That big data is not just big because of its volume, its size, but it's also big because of the variety, because of the types of linkage it is establishing through that particular data set. There are also other parameters that define what a big data has. And some of these parameters are resolution, indexicality, relationality, so on and so forth. But the three key traits remaining, that volume, velocity, and variety. So now let's look at one of the key working principles behind the idea of big data. What establishes its volume, what establishes its size, what establishes, most importantly, the variety or the linkage between the data points. And one of the methodologies, one of the working principles that guide this is the concept of ontology. So, what is ontology? In that sense, there is no exact definition of ontology, and it refers to the nature and being of things and materials in space, in society. So you would see the usage of ontology being used in across disciplines of humanities, social sciences, and computer sciences. But the idea of ontology is not really used identically across these fields, but it does refer to the idea of nature and relations of being. Um, and also as a lens, as a tool to organize knowledge. So this is a parameter that sort of is omnipresent in the idea of ontology, respective of its disciplinary orientation. Is that ontology refers to the skill set, the tool that helps us organize knowledge. And it is also a way to convey a theory or to represent a class of things. Now, this becomes important, particularly in the context of big data, that when we classify, when we categorize, what are some of the logics, some of the theoretical orientations, some of the linkages that we try to establish when we call a category, when we call a class of things a class of things. So, ontology then becomes a specification of conceptualization. Now, how we conceptualize matters. And this conceptualization goes a long way to define whether we would put a particular data representation in a hierarchy, or we would put it in a cluster, or we would put it in a category. So these decisions that we make come from this background, ongoing principle of ontology. Now, ontology is, the idea goes back as way back into the 5th century BC, when Empedocles divided the world into four primary elements: earth, fire, water, and air. And so you see that, from there we have the journey of categories, the journey of dividing a conceptualization, into clusters or into categories, to have an understanding that one is different from the other, or they can be overlapping, but there is some sense of difference between the categories. So from here, ontology has sort of evolved over time, over decades, over paradigms. And today, when we are in the digital moment, when we are looking at concepts of big data and social science research, or big data oriented research in other fields, some of the areas of application of ontology that we find is indexing. When we index something, when we classify something, indexing is one area. Artificial intelligence is definitely governed by this principle of ontology. We see the presence of ontology in software design, molecular biology, e-commerce, the semantic web, for example. So ontology prevails sort of omnipresent sense across these areas. And irrespective of the type of data, when I say type of data, it can be numbers, it can be texts, it can be audio. Irrespective of the type of data, the type and form of data, ontology gives us the premise to actually analyze and identify the particular data set that we are looking at. So, how we represent that knowledge system. So, there are certain tools, some are open access, some are subscription based, that you can look up, particularly in the context of big data, particularly in the context of when the data is more quantitative, that will help you working with the idea of ontology, the premise of ontology, such as Prodigy is a wonderful tool that you can look up. So, what happens in these tools is that when you the journey to arrive at a class or a category starts from a journey of a concept. And conceptualization is equally important across any domain or form of data that you want to look at. So, conceptualization or concept sort of is a starting point to think about ontology. So when you conceptualize something, in your data, what triggers is in your mind a form, right? A referent. And from that conceptualization, you start making connections. And these connections come at various levels. So, conceptualization, if it is level one, the next level is to, define that concept in its terms of inclusive and exclusive criteria. that not all concepts are identical to each other. So, what makes somebody think that one, say, concept one is different from concept two? So, behind the scene, what goes on is this inclusion and exclusion criteria, that what goes in the definition of a concept. So, what happens in the process is that we arrive at a classification system, that we start with a primary concept that takes us to a further, more refined idea of a category. And then in the end, we have a most, sort of sophisticated understanding that is often called a code. And this code can be in numerical terms, this code can be in qualitative terms, but the code is possibly the most sophisticated way to represent that data. So, there is a classic example to understanding how ontologies create classes and subclasses. And this is one of those classic definitions of understanding how to make a cup of tea. So, for example, when you make a cup of tea, what are some of the concepts that you would need to define that will go in the recipe of making a tea, for example? So you will, need an ingredient. You would need utensils. There would be certain actions involved, and there would be certain measurements involved. So each of these, say, ingredients and utensils, actions and measurements, would become the starting concepts. And underneath each of these concepts would be further classifications. Say, for example, under ingredients, you will have classification of tea or tea leaf, or water or milk or lemon, or so on and so forth. So this is an example of how you conceptualize, and then under each conceptualization, you would need, several subclasses or subclassification, and then further up, you would also need sub classification. So this is a very, classical example that is commonly used in understanding how ontologies work. But what happens here in this context of understanding social science research in the context of the digital is that the way that ontologies are performed has given rise to a whole series or generations or versions of the World Wide Web. So we have a Web 1.0, which was the static web, that you have website with static information, and there is no interactive feature, and it's just information that you're looking at. Web 2.0, which comes after that, is the social web. And 3.0, Web 3.0, is the semantic web. So this is where the ideas of ontology starts getting more refined. And Web 4.0, which is the intelligent web, and 5.0 is the immersive web that we are currently living in. So from the static web to the social web to the semantic web to the intelligent web to the immersive web is where we are currently living in, is really a journey of these ontologies that are related to the concept of knowledge representation. So, how we choose to represent our knowledge is guided by the idea of the type of data that we are looking at, and the type of performance, the type of functions that are made available to us because of the presence or absence of technology. So, this is again a classic example of the journey of the World Wide Web from Web version 1.0 to Web version 5.0, that we see, an evolution of ontology in the process of informing how big data or linked data has been used and represented in knowledge representation contexts. So I'm going to conclude this part of my lecture here. And in the next part of my lecture, I will continue talking about the qualitative dimension of knowledge representation and ontologies. Thank you very much.